Methods of measuring price elasticity of demand. Price elasticity of demand measures how much the quantity demanded of a product changes when its price changes. There are 5 main methods to calculate PED, each with a different approach. Let's go through them one by one in simple terms. 1. ARC method, average elasticity method, explanation. This method calculates average elasticity over a range of prices and quantities rather than at a single point. It is useful when the price change is large. Formula ED equals a frac Q2 minus Q1, Q2 plus Q1, wider frac P1, P2, where Q1 equals original quantity demanded, Q2 equals new quantity demanded, P1 equals original price, P2 equals new price. Example: if the price of a product changes from 10 to 15 and the demand changes from 100 units to 80 units, we use the formula to get the elasticity. Key point: used for big price changes because it gives a more accurate average elasticity. Half 2. Total outlay method, total expenditure method. Explanation: this method checks how total revenue, price, quantity, changes with price changes. It classifies elasticity into 3 types. Unitary elasticity: if total revenue remains constant when price changes. Elastic demand: if total revenue increases when price falls and decreases when price rises. Inelastic demand: if total revenue decreases when price falls and increases when price rises. Example: suppose a product's price falls from 20 to 15. If total revenue increases, demand is elastic. If total revenue remains the same, demand is unitary elastic. If total revenue decreases, demand is inelastic. Key point: easy method based on revenue changes instead of complex calculations. Proportionate method, percentage or ratio method. Explanation: this method calculates elasticity as a ratio of the percentage change in quantity demanded to the percentage change in price. Formula: ED % change in quantity demanded, change in price. Example: if price increases by 10% and demand decreases by 20%, then ED equals frac minus 2. Since ED (1) demand is elastic. Key point: simple percentage-based calculation that shows how sensitive demand is to price changes. 4. Point method, geometric method. Explanation: measures elasticity at a specific point on a demand curve rather than over a range. It is calculated using the slope of the demand curve. Formula: ED frac's lower segment of demand curve, upper segment of demand curve. Example: on a straight line demand curve, if the lower segment is 4 and the upper segment is 2, then ED equals 4, 2 equals 2. Since ED equals 1, demand is elastic. Key point: useful for graph-based analysis, commonly used in economics. 5. Revenue method. Explanation: this method, given by Joan Robinson, calculates elasticity using average revenue, AR, and marginal revenue, MR. Formula: ED equals a frac A minus M, where A equals average revenue, M equals marginal revenue. Example: if a firm's average revenue is 100 and its marginal revenue is 60, then ED equals frac 100. 100 minus 60 equals frac 140 equals 2.5. Since ED1, demand is elastic. Key point: focuses on firm revenue analysis, helpful for business takeaways. 1. ARC method, used for large price changes, calculates average elasticity. 2. Total outlay method, based on total revenue changes to determine elasticity. 3. Proportionate method, compares percent change in quantity versus percent change in price. 4. Point method uses graphical approach to measure elasticity at a specific point. 5. Revenue method uses AR and MR to determine elasticity, useful for businesses. Each method has its own application, and businesses use different approaches based on their needs. Example: calculating price elasticity of demand. Step 1. Understanding the given data. We are given 2 sets of price and quantity values. Initial price, P equals 20, new price, P2, initial quantity demanded equals 30 kilogram, new quantity demanded Q2, P equals 50 kilogram. We calculate the changes. Change in price, delta P equal P2, P1 equals 16 minus 20 equal minus 4. Change in quantity, del Q, Q2 minus Q1 equals 50 minus 30, 20. Step 2, using the price elasticity formula. The formula for price elasticity of demand ET is EP equal frac delta Q delta P times frac P1 Q1. Substituting the values, EP equal frac 20, 9 to 4, 20, 30. EP equals 9 to 5 times 0.67. EP equal minus 3.33. Step 3. Interpreting the result. The negative sign shows the inverse relationship between price and demand. As price falls, demand rises. Elasticity equals 3.33, which is greater than 1, meaning demand is elastic, not inelastic, as the textbook states. Elastic demand means a small price drop leads to a large increase in quantity demanded. Key takeaways. Formula, EP frac delta P times frac P1, Q1. If EP equal to 1, demand is elastic, responsive to price changes. If EP1, demand is inelastic, less responsive to price changes. If EP equals 1, demand is unitary elastic, equal percentage change in price and demand. Since 3.331, demand is elastic, meaning consumers react strongly to price changes. Example, calculating price elasticity of demand for CDs. Step 1. Understanding the given data. We have two sets of price and quantity values for CDs. Initial price, P1 equals 20. New price, P2. Initial quantity demanded, Q1, equal 100 CDs. New quantity demanded, Q2, equals 87 CDs. Now let's calculate the changes. Change in price, del P, equals P2. P1 equals 22 minus 20 equals 2. Change in quantity, del Q, equals Q2 minus Q1, equals 87 minus 1/3. Step 2. Using the price elasticity formula. The formula for price elasticity of demand, ET is EP equals frac delta Q delta P times frac P1 Q1. Substituting the values, EP equals frac 9 to 13 2 times frac 2100. EP equals minus 6.5 times 0.2, EP minus 1.3. Step 3. Interpreting the result. The negative sign shows the inverse relationship between price and demand. As price rises, demand falls. Elasticity equals 1.3, meaning demand is elastic, not inelastic, as the textbook states. Elastic demand means consumers are sensitive to price changes. If price increases by 1%, quantity demanded decreases by 1.3%. Key takeaways. Formula EP equal delta Q delta P times frac P1 Q1. If EP1 then, demand is elastic, responsive to price changes. If EP1, demand is inelastic, less responsive to price changes. If EP equals 1, demand is unitary elastic, equal percentage change in price and demand. Since 1.31, the demand for CDs is elastic, meaning people reduce purchases significantly when the price increases. Howard example 3. Calculating price elasticity of demand at 14s. Step 1. Understanding the given data. We are given price and quantity demanded for different price levels. We need to calculate price elasticity when price changes from 14 to 12. Initial price P1 equals new price P2 equals 12s. Initial quantity demanded Q1, new quantity demanded Q2 equals 60 kilograms. Now, let's calculate the changes. Change in price, delta P, P2, P1 equals 12 minus 14, minus 2, 2. Change in quantity, delta Q equals Q2 equals 60 minus 40 equals 20. Step 2, using the price elasticity formula. The formula for price elasticity of demand, E, is EP equals frac delta Q delta P times frac P1 Q1. Substituting the values, EP frac 20 minus 2 times frac 14 40. EP equals minus 10 0.35. EP 0.5. Step 3, interpreting the result. The negative sign shows the inverse relationship between price and demand. As price decreases, demand increases. Elasticity equals 3.5, meaning demand is highly elastic, not inelastic as the textbook states. Elastic demand means consumers are very sensitive to price changes. If price decreases by 1%, quantity demanded increases by 3.5%. Key takeaways. Formula, EP equal frac delta Q delta P times frac P1 Q1. If EP1, demand is elastic, responsive to price changes. If EP1, demand is inelastic, less responsive to price changes. If EP equals 1, demand is unitary elastic, equal percentage change in price and demand. Since 3.5 to 1, the demand for this commodity is elastic, meaning that when the price drops, demand increases significantly. Example 4. Calculating price elasticity of demand. Step 1. Understanding the given data. We are given the initial and new prices and quantities. Initial price P1 equals 10, new price P2 equals 9. Initial quantity demanded Q1 equals 2,000 units. New quantity demanded Q2 equals 2,500 units. Now let's calculate the changes. Change in price delta P equals P2 minus P1 equals 9 minus 10 minus 1. Change in quantity delta Q, Q2 minus Q1 equals 2,500 minus 2,000 equals 500 mon. Step 2. Using the price elasticity formula. The formula for price elasticity of demand E is EP equals a frac delta Q delta P times frac P1 Q1. Substituting the values, EP equals frac 500 minus 1 times frac 10, 2,000. EP equals 500 times 0.005. EP is 2.5. Step 3. Interpreting the result. The negative sign shows the inverse relationship between price and demand. As price decreases, demand increases. Elasticity equals 2.5, meaning demand is elastic. If price decreases by 1%, quantity demanded increases by 2.5%. Key takeaways. Formula EP frac delta P times frac P1 Q1. If EP1, demand is elastic, consumers react significantly to price changes. If EP1, demand is inelastic, consumers do not react much to price changes. Since EP equals 2.5, demand is elastic, meaning a small price drop leads to a large increase in demand. Example 5. Price elasticity of demand for airline tickets, midpoint method. This example calculates how sensitive business travelers and vacationers are to price changes in airline tickets from Mumbai to Goa using the midpoint method. Step 1. Understanding the given data. We have the following data. Price, quantity demanded, business travelers, quantity demanded, vacationers. Step 1. Understanding data. 2,000, 2,000, 800, 2,500, 900, 600. The price increased from 2,000 to 2,500, and we need to calculate the price elasticity of demand for both business travelers and vacationers. Step 2. Midpoint method formula. The midpoint formula for price elasticity of demand is EP equals frac Q2 minus Q1, left frac Q1 plus Q2, 2, right div frac P2 minus P1, left frac P1 plus P2, right, where minus P1 equals initial price, P2 equals new price, Q1 equals initial quantity demanded, Q2 equals new quantity demanded. Step 3. Elasticity for business travelers. Using the given data, P1 equals 2,000, P2 equals 2,500, Q1 equals 2,000, Q2 equals 1,900. Now applying the formula, EP equals frac 1,900 minus 2,000, frac 1,900 plus 2,000, 2 dev, 2,500 minus 2,000, 2 right, and EP equal frac 100, 150, 590, EP equals 9 is 0.05, div 0.22. EP equals 0.23. The demand for business travelers is inelastic, EP1, meaning business travelers are less sensitive to price changes. Step 4. Elasticity for vacationers. Using the given data, P1 equals 2,000, P2 equals 2,500, Q1 equals 800, Q2 equals 600. Applying the formula, EP equals frac 600 minus 800, left frac 600 plus 800, 2 right, div frac 2,500 minus 2,000, left frac 2,000 plus 2,500, 2. EP equals frac 9 is 200, 700 to rack 550, EP minus 0.29.22. Interpretation. The demand for vacationers is elastic, EP1, meaning vacationers are highly sensitive to price changes. Key takeaways. Midpoint formula is used to find a more accurate measure of price elasticity. Business travelers' demand is inelastic. 9 is 0.23. They continue buying tickets, even if prices rise. Vacationers' demand is elastic, Mangum 0.32. They reduce ticket purchases significantly if prices rise. Luxury or non-essential travel is more price-sensitive than business travel. Income elasticity of demand. Income elasticity of demand measures how the quantity demanded of a good changes when a consumer's income changes. It helps businesses understand whether a product is a necessity, luxury, or inferior good. Formula: EY equals frac change in quantity demanded, change in income, or EY equals frac delta Q, delta Y times frac YQ, where EY equals income elasticity, Q equals initial quantity demanded, Y equals initial income, delta Q, change in quantity demanded, delta Y equals change in income. Types of income elasticity of demand. 1. High income elasticity. EY1, demand increases more than the increase in income. Example: luxury goods like branded clothes, international vacations. If income rises by 10%, demand rises by 20%. 2. Unitary income elasticity. Demand changes in the same proportion as income. Example: dining out at restaurants. If income rises by 10%, demand also rises by 10%. Low income elasticity. Demand increases less than the increase in income. Example: staple food items like rice, wheat. If income rises by 10%, demand rises only by 5%. For zero income elasticity, EY equals 0, demand remains unchanged despite income changes. Example: essential medicines, salt. People buy the same amount no matter their income. Negative income elasticity. EY0 decreases as income increases. Example: inferior goods like cheap instant noodles, secondhand clothes. When income increases, people shift to better alternatives. Key takeaways. Luxury goods have high income elasticity, while necessities have low income elasticity. Inferior goods have negative income elasticity. Businesses use income elasticity to forecast sales based on economic conditions. Government policies on taxation and subsidies can be based on income elasticity trends. Calculating income elasticity of demand. Income elasticity of demand measures how much the demand for a product changes when a consumer's income changes. Example 7, elasticity calculation. Given data, initial income, Y1 equals Y has 100, initial demand, Q1 equals 25 units, new income, Y2 equals 150, new demand, Q2 equals 30 units. Step 1, find the changes. Delta Y equals Y2 is Y1 equals 150 minus 100 equals 50. Delta Q equals Q2 minus Q1, 30 minus 25 equals 5. Step 2, apply the formula. EY equals frac delta Q delta Y times frac Y1, EY equals U frac 5, 50 times I frac 2, 5 equals 0.4. Interpretation. Since 0.4 is less than 1, the demand is inelastic. Demand changes less than the income change. Example 8, income elasticity for sugar. Given data, income increase equals 10%, sugar consumption increase equals 5%. Step 1, apply the formula. EY equals frac text change in quantity demanded, change in income. EY frac 510 equals 0.5. Interpretation. Since 0.5 is less than 1, the demand for sugar is inelastic, meaning it does not increase proportionally with income. Key takeaways. If EY1, demand is elastic, luxury goods. If EY equals 1, demand changes at the same rate as income. If 0 EY1, demand is inelastic, necessities like sugar. If EY is 0, the good is inferior, e.g. demand for cheap food drops when income rises. Difference between price elasticity and income elasticity. Price elasticity and income elasticity both measure how demand changes, but they focus on different factors. Basis of difference: price elasticity of demand, income elasticity of demand. Definition: measures how demand changes when price changes, measures how demand changes when income changes. Formula: EP equals change in quantity demanded, PA text change in price. EY equals sec change in quantity demand income. Sign. Usually negative because demand decreases when price increases, inverse relationship. Can be positive or negative. Positive for normal goods, negative for inferior goods. Nature, if EP1, demand is inelastic, necessities. If EP1, demand is elastic, luxuries. If EY11, the good is a necessity. If EY1, the good is a luxury. If EY0, the good is inferior. Key takeaways. Price elasticity focuses on how demand reacts to price changes. Income elasticity focuses on how demand reacts to income changes. Price elasticity is usually negative, while income elasticity can be positive or negative. Luxury goods have high income elasticity, while necessities have low income elasticity. Cross-elasticity of demand. Cross-elasticity of demand measures how the demand for one good changes when the price of another good changes. Formula, EC equal frac text, change in quantity demanded of good X, change in price of good Y. Or EC equals frac delta QX delta PY, frac PY QX, where EC equals cross-elasticity of demand, QX equals original quantity demanded of good X, PY equals original price of good X equals change in quantity demanded of good X, delta PY equals change in price of good Y. Types of cross-elasticity of demand. 1. Substitute goods, positive cross-elasticity. If two goods are substitutes, an increase in the price of one leads to an increase in demand for the other. Example, Pepsi and Coca-Cola. If the price of Pepsi increases, people will buy more Coca-Cola. Key point, higher positive elasticity means stronger substitutability. Not 2. Complementary goods, negative cross-elasticity. If two goods are complements, an increase in the price of one leads to a decrease in demand for the other. Example, printers and ink cartridges. If the price of printers increases, fewer printers will be bought, reducing demand for ink cartridges. Key point, the more negative the elasticity, the stronger the complementarity. Independent goods, 0 cross-elasticity. If two goods are unrelated, a change in the price of one does not affect the demand for the other. Example, movie tickets and bread. A change in the price of movie tickets will not impact the demand for bread. Key point, cross-elasticity is 0 for independent goods. Key takeaways. Cross-elasticity shows how goods are related, substitutes, complements, or independent. Positive cross-elasticity means substitutes, negative means complements, and 0 means no relationship. Businesses use cross-elasticity to set prices and understand market competition. Advertising and promotional elasticity of demand. Advertising elasticity of demand measures how much demand for a product changes when a business increases or decreases its spending on advertising and promotions. Formula, EA equal change in demand, text, change in advertising expenditure. Types of advertising elasticity. 1. 0 elasticity. Advertising has no impact on sales. Example, essential goods like salt. No matter how much a company advertises, people won't buy more than they need. 2. Less than 1, EA1, inelastic demand. Sales increase less proportionately than advertising expenditure. Example, a luxury car brand spends 20% more on ads, but sales increase by only 5%. Equal to 1, EA equals 1, unitary elasticity. Sales increase in equal proportion to advertising expenditure. Example, a company doubles its ad budget and sales also double. 4. Greater than 1, EA equals 1, elastic demand. Sales increase more than proportionately compared to advertising expenditure. Example, a new mobile brand increases ad spending by 20% and sales rise by 50%. Key takeaways. If advertising has no impact, it's ineffective. Luxury and brand-driven products often have high advertising elasticity. Essential goods usually have low or 0 advertising elasticity. Businesses use this to decide how much to spend on advertising.